We're going to explain how to convert PyTorch models to Core ML and TensorFlow. 1. Converting PyTorch to Core ML. PyTorch doesn't have direct built-in conversion to Core ML. We need a bridge, a tool like Core ML tools. First, ensure you have Core ML tools installed. Pip install Core ML tools. Then, you'll need your PyTorch model saved, typically as a write single quote .pth write single quote file. The conversion process involves loading your PyTorch model, defining the input and output shapes, and using Core ML tools functions to convert it. There might be some pre-processing or post-processing needed depending on your model architecture and the specific layers used. For example, you might need to convert certain PyTorch operations into their Core ML equivalents. Once the conversion is complete, Core ML tools will save your model in the Core ML format, usually a write single quote .ml model write single quote file, ready for deployment in iOS or macOS apps. 2. Converting PyTorch to TensorFlow. This conversion is more straightforward. PyTorch and TensorFlow share a lot of underlying mathematical concepts. The process typically involves exporting your PyTorch model's state dictionary, weights and biases, and architecture. You can then reconstruct your model in TensorFlow using the saved weights. Libraries and tools exist to assist in this mapping, potentially handling layer-by-layer transfer. Note that direct conversion might not be perfect, and you may encounter minor discrepancies in accuracy due to differences in implementation details between frameworks. There are tools to assist in this process, aiming to make the transfer as accurate as possible. 3. Challenges and considerations. Regardless of the conversion path, challenges can arise. Complex custom layers in PyTorch might not have direct equivalents in Core ML or TensorFlow, requiring manual implementation or approximation. Quantization, reducing the precision of model weights and activations, is often needed to optimize model size and performance in deployment, and both Core ML and TensorFlow offer quantization tools. Finally, thorough testing is crucial after the conversion to ensure the converted model performs as expected, matching its PyTorch counterpart in terms of accuracy and speed. Remember to consult the official documentation for Core ML tools and TensorFlow for detailed instructions and best practices. The specific steps will depend on your model's architecture and the chosen conversion method.